With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Two blocks of masses 10 kilograms and 20 kilograms moving at speeds 10 meter per second and 20 meter per second, respectively in opposite directions, approach each other and collide. If the collision is completely inelastic, find the thermal energy developed in the process. So we have two blocks of masses 10 kg and 20 kg, and they are moving at speeds 10 meter per second, 20 meters per second, respectively in opposite direction. So if 10 kg mass is moving at 10 meter per second, then the 20 kg mass is moving in the opposite direction with 20 meter per second. Therefore, let this be mass 1 and this be mass 2. Then the initial velocity u of mass 1 will be 10 meter per second, and the initial velocity of mass 2 will be 20 with a negative sign, 20 meter per second, since it's going in the opposite direction. The initial momentum of this system, the whole system, let's consider both the masses to be part of the system. Then the initial momentum is equal to summation of mass into velocity. Therefore, we have 10 into velocity is 10 plus the 20 kg mass 20 into the velocity is minus 20 equal to 100 minus 400 equal to minus 300 kg meter per second. This is the momentum initial. We are told that this is an completely inelastic collision. So after collision, both these masses will join together and move with a common velocity v. So if we write the momentum final, then it will be the addition of both the masses 10 plus 20 multiplied by the common velocity capital V, kg meter per second. Now since in this system there is no external force acting, the initial and final momentum will be same. Therefore, we can equate those. So initial momentum is 300 and final momentum is 10 plus 20 equal to 30 into V. This implies capital V is equal to minus 10 meter per second. In inelastic collision, the momentum is conserved, but the kinetic energy is not conserved. Therefore, if we write the initial and final kinetic energies, initial kinetic energy will be equal to half into the kinetic energy of first mass will be half into 10 into 10 square plus the kinetic energy of second block is half into 20 into minus 20 square. So we get 500 plus 4000. This is equal to 4500. The final kinetic energy will be equal to, now both the masses are combined together, so their combined mass will be 30. So half into 30 into their common velocity minus 10 whole square is equal to 1500 joules. So the change in kinetic energy delta Ke is equal to initial kinetic energy minus final kinetic energy. So 4500 minus 1500 which is equal to 3000 joules. And this change in kinetic energy is liberated as thermal energy. Therefore, we can say that thermal energy developed is equal to 3000 joules.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.